Question number 27. A combination of two thin convex lenses of equal focal length is kept separated along the optic axis by a distance of 20 cm between them. The combination behaves as a lens system of infinite focal length. If an object is kept at 10 cm from the first lens, its image will be formed on the other side at a distance x from the second lens. Then what is the value of x? Or we have to find out the value of x. So first of all, the resultant focal length of the combined system in which two lenses are separated by a d distance of focal length f1 and f2 is 1 by f is equals to 1 by f1 plus 1 by f2 minus d divided by f1 f2. According to question, the combination behaves as a lens system of infinite focal length or f equals to infinite, and given that f1 equals to f2 or same lenses, so 1 by 0 is equals to 1 by f1 plus 1 by f1 minus d divided by f1 square. That implies f1 equals to d by 2, that is equals to 10. So that implies f1 equals to 10 centimeter, or the focal length of first and second lens is the same, and that is equals to 10 centimeter. Now we know that if an object is placed at the focal length or focus, then its image will form at infinite, or if an object is placed at infinite, then its image will form at a focal length or focus. So according to the question, it is mentioned that an object is placed at a 10 centimeter from the first lens. It means it is kept at a focus, so its image will form at infinite, and that infinite image will behave as an object for the second lens, and for the second lens its focal length will form at its and for the second lens its image will form at focus. It means the distance of the final image from the second lens is 10 centimeter. MSQ question number 31. The concept of photo emission of the electrons is that when ultraviolet radiation falls on a metallic plate, electrons are ejected from the surface. The phenomena of emission of electrons on shining light on metallic surfaces is known as photoelectric effect. And the main results of the photoelectric effect is that first one, electrons are ejected from the metal almost instantaneously, say within 10 to the power minus 9 seconds, however weak be the source. Second one, for a given metal there is a cutoff frequency lambda naught such that a beam of light of wavelength larger than lambda naught does not cause electrons to be ejected from the metal, however strong be the source. And third one, the maximum kinetic energy of the photoelectrons for a metal depends only on wavelength of the light and not on its intensity. Similarly, the number of emission of the electrons or photoelectrons depends on the intensity of the light, doesn't depends on wavelength. So according to option A, kinetic energy of electron increases with the intensity of incident light. No, that option is wrong, because kinetic energy of electron increases with the wavelength of the incident light, or frequency of the incident light. Option B, electrons are emitted when the wavelength of incident of the light is greater than 2 threshold frequency. No, the electrons are emitted when the frequency of light is greater than 2 threshold frequency, or wavelength of light is less than 2 threshold frequency. Option C, photoelectric effect is instantaneous with the incident of light. And option D, photoelectrons are emitted whenever a gas is irradiated with ultraviolet light. So option A, B and C are only incorrect options. So according to question, only A, B, C and correct option. MSQ question number 40. The instantaneous position of x is the function of time of a small block performing one-dimensional damped oscillation is x of t is equals to a e to the power minus gamma t cos omega t plus alpha, where omega is the angular frequency, gamma is damping factor, a is initial amplitude and alpha is initial phase. In this question we have to find out the initial amplitude a and initial phase alpha. To calculate these values, the initial boundary conditions are the position at time t is equals to 0 is equals to 0, and the first derivative of the position with respect to time at t is equals to 0 is v. So first of all, given that x is equals to a e to the power minus of gamma t cos of omega t plus alpha. So by putting the value t is equals to 0 in this equation, or x at t is equals to 0 equals to 0, that implies a cos alpha equals to 0, or alpha equals to 2n plus 1 pi by 2, because alpha is a 0 at value of a odd integer value of a pi by 2. Similarly, the first derivative of the position, that is equals to dx upon dt is equals to minus a e to the power minus gamma t omega sin omega t plus alpha. At time t is equals to 0, dx upon dt at time t equals to 0 equals to v, that implies a, that is equals to v by omega. So according to option C is only correct option. NAT question number 41. The superposition of two harmonic oscillations in the same direction results in the oscillation of a point according to the equation x equals to a cos 2.1 t cos 50 t, where t is time and a is the resultant amplitude. In this question, we have to find out the period in which the superpositions will beat. So given that x is equals to a cos of 2.1 t cos of 50 t. So by separating the oscillations in its individual oscillations, we know that a cos of at cos of bt is equals to a cos of a plus b into t plus cos of a minus b into t. By using this formula, x is equals to a cos 50 plus 2.1 t plus cos 50 minus 2.1 into t. That implies x is the superposition of two harmonic oscillations, and these equations are x1 equals to a cos of 52.1 t and x2 is equals to a cos of 47.9 t, where omega 1 is 52.1 per second and omega 2 equals to 47.9 per second, or corresponding frequency n1 equals to 52.1 divided by 2 pi and n2 is equals to 47.9 divided by 2 pi. Or the beats will be change in frequencies n1 minus n2, that will be equals to 52.1 divided by 2 pi minus 47.9 divided by 2 pi, that is equals to 0.668 hertz. That implies the interval between maximum or minimum beats will be equals to 1 divided by n1 minus n2, and that will be equals to 1.497 second. The answer is 1.4 to 1.5 second.